The ancient Egyptian pyramids are one of the most enduring architectural marvels in human history. These colossal structures have fascinated scholars, archaeologists, and enthusiasts for centuries, leaving us in awe of the engineering prowess and cultural significance they represent. However, despite extensive research, exactly how the pyramid was built remains a mystery. With modern-day tools and know-how, scientists have not determined a way to recreate the pyramids, even on smaller scales, with the same precisions as those who built the originals. That raises a question. If we can't recreate the Great Pyramid at Giza, then how did the Egyptians accomplish such a magnificent feat? Was there an advanced civilization that helped? Things got more complex when recent discoveries showed that these extraordinary monuments might be older than previously believed, hinting the Great Pyramid may predate the Egyptians, and its existence may be a mark on Earth of a once more advanced civilization. Join us as we dig deep into the evidence that fuels the controversial hypothesis that could upend our history book. Great Pyramids. According to conventional Egyptology, the pyramids of Giza are not only a testament to ancient Egyptian culture, but also to their incredible ingenuity. Built some 4,500 years ago, these tombs were erected to house the remains of deceased pharaohs. After death, part of the pharaoh's spirit was thought to remain with the body, so it required special care to ensure the deceased ruler could carry out their responsibilities as a god in the afterlife. Each pyramid also provided a form of storage, as they were filled with the various possessions a former ruler would need in the next world. The largest and oldest pyramid at Giza belongs to Pharaoh Khufu and was built around 2550 BCE. It is estimated to be made of about 2.3 million stone blocks, each weighing between 2.5 to 15 tons. It's worth bearing in mind the astonishing precision and intricacy with which the pyramids were built. The pyramids were constructed on a north-south alignment with an accuracy of up to 0.05 degrees, with stones that were leveled across its entire base within a fraction of an inch. The second pyramid was built by Khufu's son, Khafre, circa 2520 BCE. Khafre's necropolis, a large cemetery with elaborate tomb monuments, also includes the Sphinx, which guards the site. The third pyramid, the smallest, was built by Pharaoh Menkaure circa 2490 BCE. Originally, each pyramid stood taller than today, as they would have been encased in smooth white limestone. However, over the centuries, these casings have been removed and plundered, along with most of the grave goods the pyramids once contained. Scientists over the years have studied the Great Pyramid and pondered what it must have taken at that time to construct such a wonder. Many believe that the Egyptians actually created these monuments with a combination of rudimentary tools: plumb bobs, stings, rope, wood, stone hammers, sleds, copper chisels and saws, and well-known mathematical and engineering techniques. Essentially, a pyramid is a cube where the sides meet in the center through a series of increasingly smaller rectangles stacked on top of one another. So, to create a pyramid, you only needed a rectangle as a base to build from. Establishing this was pretty straightforward and could be achieved by using set squares to lay out and check right-angle triangles, while the plumb bob could measure vertical adjustments. Once the base was established, each subsequent layer became smaller, which required precision calculations. Then the outer stones had to be cut to create a smooth inclined surface for the sides. The blocks were slid into place using wooden logs, and then masons chiseled them into shape with copper chisels. It is even possible to see the markings on some blocks where the chisels needed to be sharpened. It is also likely the Egyptians used a ramp and embankment method to position the blocks at higher points on the pyramid. Gangs of workers would haul each block up ramps using sleds, rollers, and levers. As the pyramid grew, more sand, bricks, and earth would be added to raise the embankments to support the ramps. There have been various suggestions on the exact configuration of the ramps, but evidence from recent archaeological finds shows that the ancient Egyptians had experience using ramps to move heavy stone blocks. Regardless, researchers believe that the secret to the Egyptians' ingenuity wasn't in some spectacular and long-lost technology or arcane knowledge, but in the size of their workforce and years of labor. According to their estimates, it took 20,000 workers 20 years to finish the Great Pyramid. This would be an astounding task when our history shows that they only used wooden implements with ropes and pulleys. However, due to there being such detail and precision alignments of the pyramid, it's hard to believe that such a magnificent structure could be completed in 20 years with so few people and such limited tools and resources of that period. As a result, despite all the study and examination by scientists, exactly how the pyramid was built remains a mystery. The technology to do so in that era simply didn't exist according to historical teachings. It shouldn't have been possible to construct the pyramids when they were built. Adding to the mystery of the Great Pyramid, it is the only one of the 7 wonders of the world to remain mostly intact. The pyramids are older than Egypt's advanced civilization. Skeptics even point out some fairly reliable shreds of evidence to suggest that the pyramids may predate the Egyptians and that the pyramids may be a mark on Earth of a once more advanced civilization, more than 4,500 years ago. One intriguing piece of evidence challenging the established timeline is the erosion patterns found on the Sphinx. While the mainstream view attributes the Sphinx to Pharaoh Khafra's era, some geologists and researchers argue that the erosional features on the monument are indicative of water erosion, possibly caused by heavy rainfall. The Sahara Desert, where the pyramids are located, experienced significantly wetter periods in ancient times, and some argue that this level of rainfall could have caused the observed water-related wear on the Sphinx. If this hypothesis holds true, it would suggest the Sphinx and, by extension, the pyramids are much older than previously assumed. Another aspect that raises questions about the pyramids' age is their precise astronomical alignments. The Great Pyramid, for instance, exhibits a remarkable alignment with specific celestial bodies, including Orion's belt. The degree of accuracy required to achieve these alignments with the limited technology available in ancient Egypt is staggering. Alternative theories propose that the ancient Egyptians possessed advanced knowledge of astronomy and mathematics, far beyond what traditional views assume. Such a level of sophistication would challenge the accepted chronology and push the construction of the pyramids back into an even more ancient past. In addition, as the studies of the Giza pyramids continue, stunning discoveries are regularly made. The tunnels found below the pyramids allude to a truly advanced civilization. Carved from bedrock made of limestone, the labyrinth of tunnels protrudes deep beneath the desert and has much left for scientists to discover. There are still new facts and new chambers being discovered that have remained unseen by man for thousands of years. While going into the deeper mazes of the pyramids, there were 20 boxes discovered that were cut with precision from Aswan granite. Each of these mysterious boxes weighed in at 100 tons apiece. Experts in the fields studying the pyramids believed they were places to bury prized bulls. The only issue is there have been no bulls ever found. Others believed that they were the storage place of ancient forms of energy. That would make more sense than the boxes being for bull burials. And beside the mysterious boxes, research on the materials in the construction also brings many surprises. The materials, specifically the mortar, have been examined, and although the composition of the mortar has been determined, our modern technology can't recreate it. The mortar was made of processed gypsum, and it wasn't used the same as the cement we use to make modern-day bricks. The Egyptians used mortar to support the joints of the giant stones as they were placed. It's estimated that 500,000 tons of mortar were used during the construction of the Great Pyramid. Amazingly, the gypsum mortar used by the Egyptians in the construction of the pyramid is stronger than the stones used in the construction. The mortar has remained in place for nearly 5,000 years. Moreover, note that carbon dating is a widely used technique to determine the age of organic materials. However, when applied to the pyramids, certain anomalies have been observed. In some cases, the results yielded dates significantly older than the established timeline. Skeptics argue that these discrepancies might be due to contamination or other factors, but proponents of an older pyramid age contend that it might indicate the presence of materials reused from earlier constructions. While the construction of the Great Pyramid is a mystery and is something out of this world, what about the position of the Great Pyramid? The short answer is that it is equally puzzling. According to measurements, the Great Pyramid is the most accurately aligned structure in existence and faces true north with only 3/60th of a degree of error. The position of the North Pole moves over time, and the pyramid was exactly aligned at one time. Even more incredibly, the Great Pyramid is located at the center of the land mass of the Earth. The east-west parallel that crosses the most land and the north-south meridian that crosses the most land intersect in two places on the Earth, one in the ocean and the other at the Great Pyramid. As you can see, the Great Pyramid of Giza is an incredible ancient construction that was erected by an extremely advanced ancient civilization. This ancient civilization had incredible knowledge in mathematics, physics, geology, and engineering. Without this knowledge, it would have been impossible for mankind to achieve such an accurate structure thousands of years ago. Things got more complicated when embedded into this incredible construction that has everyone baffled is a set of extremely complex formulas. First off, the sun's radius. Don't you know that twice the perimeter of the bottom of the granite coffer times 10 to the power of 8 is approximately to the sun's mean radius? Better yet, the weight of the pyramid is estimated at 5,155,000 tons in total. Multiplied by 10 to the power of 8 gives a reasonable estimate of the Earth's mass. Interestingly, the curvature designed into the faces of the pyramid exactly matches the radius of the Earth. All of this was achieved by ancient man thousands of years ago, without the use of power tools, lasers, advanced transportation systems, and without computers that were able to solve advanced measurements needed to erect a nearly perfect building. So, what exactly was the purpose of the Great Pyramid of Egypt? If it was not intended to serve as a tomb, is it possible that this incredible ancient structure might have had a totally different purpose? Whether it is regarding one that mainstream scientists are ignoring completely, like the Great Pyramid's power. Many people argue that these ancient structures possess unique energy fields capable of influencing various aspects of life. For instance, in 2018, an international research group has applied methods of theoretical physics to investigate the electromagnetic response of the Great Pyramid to radio waves. Calculations showed that in the resonant state, the pyramid can concentrate electromagnetic energy in its internal chambers as well as under its base, where the third unfinished chamber is located. The research group plans to use these theoretical results to design nanoparticles capable of reproducing similar effects in the optical range. Such nanoparticles may be used, for example, to develop sensors and highly efficient solar cells. What's notable, among those fascinated by the potential of pyramid energy was the renowned inventor and physicist Nikola Tesla, whose innovative ideas and experiments continue to inspire curiosity and speculation. Nikola Tesla, often regarded as one of the greatest inventors of the modern era, was known for his groundbreaking work in electricity, magnetism, and wireless communication. His visionary ideas sometimes extended into unconventional realms, including the exploration of energy and vibration beyond conventional scientific paradigms. Tesla's open-mindedness and willingness to explore unconventional ideas led him to consider the possibility of harnessing energy from various sources, including the Earth's natural forces and potentially even cosmic energies. Tesla believed that the Egyptian pyramids served a higher purpose and was investigating them throughout his life. What did he find so alluring about the pyramids? He wondered if they weren't giant transmitters of energy, a thought that coincided with his investigation into how to send energy wirelessly. In 1905, Tesla filed a patent in the US titled The Art of Transmitting Electrical Energy Through the Natural Medium, outlining designs for a series of generators around the world, which would tap the ionosphere for energy collections. He saw planet Earth itself, with its two poles, as a giant electrical generator of limitless energy. His triangle-shaped design became known as Tesla's electromagnetic pyramid. And according to Tesla, it wasn't just the shape of the Egyptian pyramids, but their location that created their power. He built a tower facility, known as the Tesla Experimental Station in Colorado Springs and Wardenclyffe Tower, or Tesla Tower on the East Coast, that sought to take advantage of the Earth's energy field. The locations were chosen according to the laws of where the pyramids of Giza were built, related to the relationship between the elliptical orbit of the planet and the equator. The design was intended for wireless transmission of energy. So, were the Great Pyramids essentially ancient Tesla towers? We don't know. And as we don't know precisely how the pyramids were built and why, they are looked at by many people, including Nikola Tesla, as creations that may be either generating energy or be serving as deliberately installed messengers or even code from an ancient civilization. It's easy to get into ancient aliens type of theories by extending such thinking. Even some researchers also suggest that the origins of the pyramids could be linked to an advanced civilization that predates ancient Egypt. The notion of lost civilizations and knowledge passed down through the ages is not new, and many cultures around the world possess legends of great civilizations that existed in the distant past. While these theories can be highly speculative, they remind us that our understanding of history is always evolving, and we must remain open to new evidence and interpretations. After all, the age of the pyramids remains an enigma, with intriguing evidence hinting at the possibility that they are older than traditionally believed. The water erosion on the Sphinx, the precision of astronomical alignments, carbon dating anomalies, and the notion of lost civilizations all contribute to the ongoing debate surrounding these ancient marvels. Regardless of the age, the pyramids will continue to captivate our imagination, serving as a testament to the ingenuity and cultural legacy of the ancient Egyptians. As technology advances and new archaeological discoveries come to light, we may eventually unravel the true mystery behind the construction and age of these timeless monuments. Until then, the pyramids will continue to stand tall, guarding their secrets, inviting us to wonder about the distant past and the ancient civilizations that once ruled the sands of time. While waiting for the mysteries to be unlocked, let's pass the time by taking a quick look at some of these puzzling lost civilizations throughout the course of human history. Çatalhöyük. Çatalhöyük stands as a fascinating testament to the ingenuity and complexity of ancient civilizations. Located in modern-day Turkey, Çatalhöyük flourished approximately 9,000 years ago, making it one of the earliest known urban settlements in the world. Spanning from around 7,500 BCE to 5,700 BCE, this Neolithic site offers invaluable insights into the social, economic, and cultural dynamics of its time. At its peak, Çatalhöyük was a bustling community, home to thousands of inhabitants. Its unique layout is one of its most distinctive features. Unlike later urban centers with organized streets and buildings, Çatalhöyük was a maze of densely packed mud brick houses built side by side and accessed through ladders and holes in the roofs. This layout suggests a highly communal way of life, where neighbors lived in close proximity and likely shared resources and responsibilities. The houses themselves were small and lacked distinct rooms, with internal divisions marked by platforms and storage bins. Each dwelling served multiple functions, acting as living quarters, workshops, and even burial sites. Evidence suggests that the dead were buried beneath the floors of the houses, indicating a deep connection between the living and the deceased within the community. Artistic expression was a prominent aspect of life at Çatalhöyük. The walls of the houses were adorned with vibrant murals depicting scenes of daily life, hunting expeditions, and religious rituals. These paintings provide valuable glimpses into the beliefs and practices of the inhabitants, revealing a rich spiritual and cultural landscape. Additionally, the discovery of intricate figurines, jewelry, and other artifacts further highlights the importance of artistic expression in Neolithic society. The economy of Çatalhöyük was primarily based on agriculture and animal husbandry. The fertile lands surrounding the settlement supported the cultivation of grains such as wheat and barley, while domesticated animals such as cattle, sheep, and goats provided vital resources such as meat, milk, and wool. The inhabitants also engaged in trade, exchanging goods such as obsidian, a volcanic glass used for tools and weapons, with neighboring communities. Religion played a central role in the lives of the Çatalhöyük inhabitants. Excavations have revealed a series of elaborate shrines within the settlement, adorned with sculptures, paintings, and animal remains. These shrines were likely used for communal rituals and ceremonies, underscoring the importance of spiritual practices in binding the community together. The decline of Çatalhöyük around 5700 BCE remains a topic of debate among archaeologists. Environmental factors such as climate change and soil depletion may have played a role, as well as social and economic pressures. Regardless of the specific reasons for its demise, Çatalhöyük leaves behind a rich legacy of innovation and resilience. In conclusion, Çatalhöyük stands as a remarkable example of early urbanism and cultural development. Its labyrinthine layout, vibrant artwork, and complex social structure offer valuable insights into the lives of Neolithic peoples and the foundations of civilization. By studying Çatalhöyük, archaeologists and historians continue to unravel the mysteries of our shared human past. The Maya. The Maya civilization flourished across the Mesoamerican region, primarily in what is now modern-day Mexico, Guatemala, Belize, Honduras, and El Salvador. Known for their advanced understanding of mathematics, astronomy, architecture, and art, the Maya Empire left a lasting legacy that continues to intrigue scholars and enthusiasts alike. The Maya civilization emerged around 2000 BCE and reached its peak during the Classic period, 250–900 CE, when powerful city-states dominated the landscape. While there was no central Maya empire in the traditional sense, the civilization was characterized by a network of interconnected city-states, each with its own ruler and government structure. These city-states were often engaged in alliances, trade, and occasional conflicts. One of the most remarkable aspects of Maya civilization was its sophisticated writing system, which combined logograms and phonetic elements. This script, often referred to as hieroglyphics, was used to record historical events, religious beliefs, and astronomical observations. Maya scribes recorded their knowledge on various surfaces, including stone stelae, pottery, and codices made from bark paper. The Maya were also renowned for their advancements in mathematics, particularly their use of the concept of zero. They developed a complex numerical system based on a vigesimal, base 20 counting system, which allowed them to perform elaborate calculations and create accurate calendars. The Maya calendar system consisted of multiple interlocking cycles, including the Hab, a 365-day solar calendar, and the Tzolk'in, a 260-day ritual calendar. These calendars were used for agricultural planning, religious ceremonies, and divination. Religion played a central role in Maya society, influencing every aspect of life from politics to agriculture. The Maya worshipped a pantheon of gods and goddesses, many of whom were associated with natural phenomena such as the sun, moon, rain, and fertility. Religious rituals and ceremonies were performed by priests and shamans, often involving bloodletting, human sacrifice, and offerings to appease the gods and ensure the well-being of the community. The architectural achievements of the Maya are perhaps best exemplified by their impressive ceremonial centers and pyramids. Cities such as Tikal, Palenque, and Copan boasted elaborate temple complexes, adorned with intricate carvings and sculptures. The towering pyramids served as both religious sanctuaries and symbols of the city-state's power and prestige. The Maya also constructed sophisticated irrigation systems, terraced fields, and raised causeways to support their growing population and agricultural needs. Trade was another vital component of Maya civilization, facilitating the exchange of goods, ideas, and cultural influences across the region. Obsidian, jade, cacao, and feathers were among the commodities traded by the Maya, who established extensive networks of trade routes connecting distant cities and regions. This exchange of goods not only stimulated economic growth, but also fostered cultural exchange and innovation. The decline of the Maya civilization is a subject of ongoing debate among scholars, with theories ranging from environmental degradation to political instability and warfare. By the end of the 10th century, many of the great Maya cities had been abandoned, their monumental structures reclaimed by the surrounding jungle. Despite their collapse, the Maya legacy endures through their impressive achievements in art, science, and architecture, serving as a testament to the ingenuity and resilience of one of the world's most fascinating ancient civilizations. The Indus Civilization. The Indus civilization, also known as the Harappan civilization, emerged around 3300 BCE in the northwestern region of the Indian subcontinent, encompassing parts of present-day Pakistan and northwest India. Flourishing for approximately 2,000 years, it represents one of the world's earliest urban societies. The civilization derived its name from the Indus River, around which many of its major settlements were established. At its peak, the Indus civilization covered an area of over 1.25 million square kilometers, making it one of the largest ancient civilizations. Its major urban centers, such as Harappa and Mohenjo-daro, showcased remarkable urban planning, featuring advanced drainage systems, well-organized streets, and sophisticated architecture. The cities were meticulously laid out in a grid pattern, indicating a high level of centralized planning and governance. Trade played a pivotal role in the Indus civilization's economy. The inhabitants engaged in long-distance trade networks, exchanging goods such as pottery, beads, metals, and gemstones, with regions as far as Mesopotamia and Central Asia. The discovery of standardized weights and measures suggests a highly regulated trade system, facilitating economic prosperity and cultural exchange. Agriculture formed the backbone of the civilization's economy. The fertile floodplains of the Indus River and its tributaries provided ideal conditions for cultivation. The Indus people cultivated a variety of crops, including wheat, barley, peas, and cotton. Advanced irrigation techniques, including canals and wells, were employed to maximize agricultural productivity. The social structure of the Indus civilization remains enigmatic due to the absence of deciphered written records. However, it is believed to have been organized into distinct social classes, with evidence suggesting the presence of a ruling elite, artisans, merchants, and laborers. Religion also played a significant role in society, as evidenced by the presence of elaborate ceremonial structures and religious artifacts. The Indus civilization is renowned for its sophisticated urban planning and engineering feats. The cities were equipped with advanced drainage systems, featuring interconnected networks of covered drains and cesspits to manage wastewater. The Great Bath of Mohenjo-daro, a large public bathing complex, is one of the most iconic structures of the civilization, suggesting the importance of ritual purification and communal activities. Art and craftsmanship flourished in the Indus civilization, as evidenced by the intricate pottery, seals, jewelry, and figurines discovered at archaeological sites. The seals, made of steatite and engraved with unique symbols, have attracted significant scholarly attention. While the script remains undeciphered, it is believed to represent an early form of writing or proto-writing. Despite its remarkable achievements, the decline of the Indus civilization remains a subject of debate among historians and archaeologists. Various theories propose factors such as environmental degradation, climate change, natural disasters, and invasions as potential causes. The gradual decline of urban centers and the abandonment of some settlements indicate a period of upheaval and transformation in the region. The legacy of the Indus civilization endures through its contributions to urban planning, trade, agriculture, and art. Its sophisticated infrastructure and cultural achievements laid the foundation for subsequent civilizations in the Indian subcontinent. The ongoing archaeological research continues to unravel the mysteries of this ancient civilization, shedding light on its significance in shaping human history. The Khmer Empire. The Khmer Empire, a remarkable civilization that flourished in Southeast Asia from the 9th to the 15th century, left an indelible mark on history with its impressive achievements in architecture, culture, and governance. Situated in present-day Cambodia, the Khmer Empire's influence extended across much of mainland Southeast Asia, encompassing parts of present-day Laos, Thailand, Vietnam, and Myanmar. The empire's origins trace back to the early 9th century, when King Jayavarman II unified disparate Khmer territories under his rule, establishing the foundation for what would become one of the most powerful kingdoms in the region. Under subsequent rulers, notably Jayavarman VII, the empire reached its zenith during the 12th century, characterized by unprecedented advancements in architecture and infrastructure. One of the most iconic legacies of the Khmer Empire is the magnificent temple complex of Angkor Wat, located near modern-day Siem Reap. Constructed in the early 12th century by King Suryavarman II, Angkor Wat stands as the largest religious monument in the world and is renowned for its grandeur and architectural sophistication. Its intricate bas-reliefs depict scenes from Hindu mythology and historical events, offering invaluable insights into Khmer society and culture. Beyond Angkor Wat, the Khmer Empire's architectural prowess is evident in other temples such as Bayon and Ta Prohm, each contributing to the rich tapestry of Khmer art and architecture. These structures, with their intricate carvings, towering spires, and expansive layouts, reflect the empire's commitment to spiritual devotion and artistic expression. The Khmer Empire's success was not solely built on architectural marvels. It also boasted a sophisticated system of governance and administration. At its peak, the empire was organized into a highly centralized monarchy, with the king wielding absolute authority over his subjects. The royal court was supported by a bureaucracy of officials who managed the empire's affairs, overseeing everything from taxation to infrastructure development. Religion played a significant role in Khmer society, with Hinduism initially serving as the state religion before being supplanted by Buddhism during the reign of Jayavarman VII. Buddhist monasteries such as Preah Khan and Ta Prohm dotted the landscape, serving as centers of learning and spiritual contemplation. The patronage of religion by Khmer rulers not only bolstered their legitimacy, but also facilitated the spread of cultural and intellectual exchange within the empire. Trade was another vital component of the Khmer Empire's prosperity, with maritime routes connecting it to distant lands such as China, India, and even the Arab world. The empire's strategic location along the maritime Silk Road enabled it to engage in lucrative trade in spices, precious metals, and luxury goods, enriching its coffers and fostering economic growth. Despite its remarkable achievements, the Khmer Empire faced internal strife and external pressures that eventually contributed to its decline. In the 13th century, the empire began to weaken due to incessant conflicts with neighboring kingdoms, environmental challenges such as drought and deforestation, and internal power struggles. By the 15th century, the once mighty Khmer Empire had fragmented, with its capital of Angkor abandoned and reclaimed by the jungle. However, its cultural and architectural legacy endured, influencing subsequent civilizations in Southeast Asia and capturing the imagination of scholars and travelers for centuries to come. In conclusion, the Khmer Empire stands as a testament to the ingenuity, resilience, and artistic brilliance of the ancient civilizations of Southeast Asia. From its awe-inspiring temples to its sophisticated governance structures, the empire's legacy continues to inspire admiration and fascination, serving as a reminder of the enduring impact of human achievement on history. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.